In Chapter 9, we're going to spend time focusing on how trigonometry relates to other topics. Specifically, we're going to look at things like surveying, navigation, area of triangles. We're going to move into a new type of coordinates we're going to talk about. We're going to look at complex numbers. Up to this point, everything that we've dealt with as far as trig goes has been a right triangle. But what happens if we have something other than a right triangle? Notice that in a triangle, there are 6 things that we know. So if you consider this triangle here, there are 3 angles and 3 sides. Well, what we're going to look at in this chapter is if we know one side and at least 2 other things, we can solve the rest. When we look at these triangles, we're going to refer to the angles as A, B, and C using capital letters, and the side opposite of the angle will be the side using a lowercase letter. We're going to look specifically at the laws of sines and the laws of cosines. With the laws of sines, we're going to be able to use 2 angles and a side, known as angle, angle, side, or angle, side, angle. So that would be something like this angle, this side, and this angle. Or we're going to use 2 sides and a non-included angle. So that might be something like side C and A, but then an angle that's not included in between them. The law of cosines, which we'll move into in a later section, deals with side, angle, side. So the angle is the one in between, or knowing all 3 sides. The theorem of the law of sines states that given a triangle with sides and angles labeled according to that convention we just discussed, the law of sines is that the sine of angle A divided by the length of side A is equal to the sine of B divided by the length of side B is equal to the sine of C divided by the length of C. Now, where does this come from? Well, consider some triangle like this. We'll again call it A. We'll call this C. So this is little a and this is little c. If we turn it into a right triangle, so we call this some side H, we know that the sine of A is equal to the opposite, which is going to be height H, over the hypotenuse, which in this case is side C. So therefore, we can multiply that out and we get C times the sine of A equals H. But notice we can also use this other right triangle and we can define the sine of C is equal to the opposite H over the hypotenuse, which for that triangle is A. And notice here I'm referring to this triangle. And there we can again solve for H and we get that A sine of C is equal to H. Well, that tells us that C sine of A is equal to A sine of C. And so if we then divide those out, we can divide here by C. We get sine of A is equal to A sine of C over C. And then if I divide both sides by A, I end up with the sine of A over A is equal to the sine of C over C. And then a similar relationship can be found using the same idea for the angles B. We'll talk later about the idea that there are 2 ways that these triangles can exist. It can either be an obtuse or an acute angle there, and we're going to look at how the law of sines and cosines plays into those 2 different types of triangles in a later lecture.